Okay, today we're working with inverses. We're going to spend a good chunk of time here talking about and really defining like what is an inverse. Okay, so when I say an inverse operation, okay, what is an inverse operation to addition? Subtraction. What's the inverse operation to multiplication? Division, right? Those are inverse, okay? A lot of times in math we use the word opposite maybe a little bit too much, okay? We really should be thinking about it more as like something that undoes, okay? So multiplication undoes division, right? It's an inverse, okay? So if I have x plus 2, what's the inverse of x plus 2? X minus 2, right? It's the opposite, or it would undo that. Whatever we're doing to x, it would undo that, okay? So that's what we're going to get into here. So first of all, what makes something a function? Hey, this is a little bit of a review, but if we think about a function, there was two ways that we can see if it is not a function. One of them had to do with one of these, a vertical line. What did we do with the vertical line to see if it's a function? If I have a vertical line and I run it through a function that looks like this, am I going to ever cross 2 points on the graph at the same time? No. So that means it's a function. Okay? The other way that we can look is if we look at the ordered pairs. So if I have 1, 3, 2, 4, 3, 3, that would be a function because the x's do not repeat. Okay? We look at the x's. The y's can repeat, the x's cannot. Okay? So that's the other way that we can see. We can look to see if any of the x's repeat. Okay? So there's the vertical line test. We just talked about that. But remember, that's something that we can use to see. All right, now inverse. We already talked about this a little bit. But when you think of inverse, what do we think of? We kind of think of opposite, right? Which is a word, like I said, we maybe overuse in math. Okay? But inverse really means like to undo, okay? So that's what we're going to have right here, okay? So inverse operations. An equation is a functions that are inverses if one another undo each other. Okay, so this is that first line right there on your notes. It's that first blank on your notes. It says, is a function an equation is a function. It's not worded the same, but it's this part right here. Oh no, that's the part that it says if a function. Never mind. All right. Okay, that was this part right here. Okay, an equation is a function if no vertical line passes through. Got ahead of myself a little bit. So the vertical line test, an equation is a function if okay, so then we get to the inverse part. Okay, so we just talked about inverse. Often we think of like opposite, but we really want to think about this. Okay, that functions that are inverses of one another undo each other. Okay, so this is almost right in the middle of your note sheet. Okay, I want you to find the word undo on your note sheet. Okay, they undo each other. So like we said, if it's plus 3, the inverse of plus 3 would be minus 3. Okay, here's a really big takeaway for us in this right here. Okay, as far as graphing, an inverse happens when a function is reflected over the line y equals x. This is where I would recommend you guys getting out your little flare pens or gel pens or whatever, okay, because your graph is not color-coded. This one is, okay? And that line y equals x is the green line right there. And that is the line that we are reflecting the function over. So the red parabola is the original parent function. That's y equals x squared. The blue one is the inverse. Okay, now, we're not going to work with these very much, okay? Like, don't worry too much about, holy cow, that's a lot of curvy lines and there's things all over the place. Okay, this one is a little bit more friendly, okay? So this is the graph that we're going to focus a little bit more on. It's the one on the right. So again, you have that green diagonal line. That's that y equals x.
Bless you.
Okay, our red line is our original function, which is the 2x plus 3. And the blue line is our inverse.
Messed up my colors, Mr. H.
A couple things I want to draw attention to on this, okay? First of all, I want you to look at the slopes here, okay? Like, this is positive 2, this is 1/2, right? Okay, like that makes sense that they're inverse of each other. Okay, the slope is 2 over 1, now it's 1 over 2. So that's the first thing you can notice. The next thing I want you to notice is this. On my red line, this point right here is 0, 3. You guys agree with that? Because it's on the y-axis, goes up 3. Okay, that same point on my blue line is right here as it's been reflected, but now it's 3, 0. What happened? The x and y did what? They flipped. The x and y switched spots. So it went from 0, 3 to 3, 0. That's what happens on every single point on this line. Okay? So whereas on the red line, it might be at, there's not another good one. Yeah, there's not another good one. But all the x and y axis is, all the x and y coordinates just flip-flop. Okay, and that is the true nature of an inverse. Okay, a couple other things just in this section of your notes that I want to highlight is this part right here. Okay, that the inverse of a function is written as f, and then it's to the negative first. It's an exponent to the negative first of x. That's how we know it's an inverse. So the original function is going to be written as f of x. And then the inverse is going to have that little baby 1. Okay? All right. From here, I think you guys are really going to like this, okay? This next slide really just talks about something we already talked about. Okay, the fraction, the operations that undo each other, okay? So multiplication undoes division, so on, okay? This is the next part. I want you to flip your paper over, and I'm going to give you 2 minutes to copy down these steps. And those of you that are real linear thinkers, like step 1, step 2, step 3, you like that order of work, this is going to be great for you. So take 120 seconds here and copy down those 4 steps. The thing I want to add here is on this, I want to just put a reminder that f of x is y. Like, we just need to remember that. That's something that we did a while ago, but f of x is just a fancy way of saying y. Okay, when we say switch the x and y values, we literally mean switch places. Okay, so like right now, if I say Ian and Emma switch spots, what are they going to do? They're going to get up, and Emma's going to walk over to Ian's seat, right? And Ian's going to get up and walk over to Emma's seat. Okay, that's what we're doing with the x and y. Okay, so let's take a look at an example here. So the first thing I'm going to do is rewrite this so I have y in my equation. So y equals 2x plus 8. That's really our step 1. Okay? Our step 2, what am I going to do with the x and y? Step 2, I'm going to flip-flop them, right? So this is my step 2 right here. X equals 2y plus 8. Right, now we're going to solve for y. We know how to do this. This goes back to when we were putting stuff into slope-intercept form. Okay, so that's going to be our next step. So what's my first thing I'm going to do? I want to isolate y. I want to isolate the y. Get y all by itself. So what am I going to do? What's the inverse of plus 8? Minus 8. What I do on the right, I do on the left. So I'm going to do minus 8. So now I have 2y equals x minus 8. Right, now what do I need to do? That's a times 2, right? Y times 2. So what's the inverse of multiplication by 2? Divide by 2. Divide by 2. So I'm going to flip this around so it's in the right order. Y equals, and remember that there's a 1 next to that x, right? So that's 1/2 x, and then that 8 over 2 would be minus 4. Okay, now this is that last step. I'm going to put this one in purple right here. Okay? We have to write this in function notation. So all that means I'm going to do is I'm going to take that y and I'm going to put f to the negative first of x equals 1/2 x minus 4. And that would be my final answer. So if it says write it in function notation, you need to have the f to the negative first. What?
Why negative 1? Wow.
Because, but now we have negative 4x over 15. Okay? So first step, I'm going to just rewrite it. Y equals negative 4x over 15. And I want you to take it from there. Just go through your steps. Step 1 here. What do I have to do? To isolate the y, what do I do? First step, James, what? How do I undo divided by 15? Times 15. So I'm going to multiply both sides by 15. Just like that. So now I have 15y equals negative 4x. Okay? So now I'm taking that x times negative 4, right? So how do I undo times negative 4? Riley, what do I do? Divide by negative 4. Divide by negative 4. So I forgot to flip-flop. But they would still be in the same spots. So this would be x, this would be y. This is x, this is y. All the math still holds true, okay? So now I have that divided by negative 4, so it cancels out on the right side. So I end up with y equals 15x over 4. And then in my function notation, it's f to the negative first of x equals 15x divided by 4.
Yeah, well, yeah.
Yep. Good catch. That should be a negative for it. I get going fast sometimes and I forget stuff like that. All right, another one. Hey, now this one we've got x minus 3 divided by 11. You know what? We're not going to do this one. What would be my first step, though? After I flip-flop, I'm going to have to do what? Multiply by 11 and then what?
Plus 3.
Add 3. Okay, we can do that. We're good. All right. Let's do this one right here. So y equals 2x cubed minus 11. One thing I have to remind you of is we are trying to isolate the thing with the exponent. So now I'm going to flip-flop my x and y. So what I'm trying to isolate is this right here, that y cubed. So I have to get rid of the plus 11 and the times 2.
But can it end with an exponent?
No, you got to get rid of that exponent too. So how do we undo the cubed? The cube root, right? If we're doing PEMDAS and we're going in order and we were solving something, it goes P, E, and then M and D, A, and S, right? So now because we're working backwards, we're undoing, we have to go this way. So first we have to undo the addition and subtraction. So that's my plus 11. So now I did that. Yep, you were right. 2y cubed equals 11. Okay, then what's next if I'm going up? I have to undo this part, multiplication or division. So I'm going to divide by 2. Divide by 2. So now I'm left with y cubed equals 11 halves.
X, right?
It should be x plus 11. Yeah, x plus 11. X plus 11 over 2.
I have it on my paper too. Cool.
Okay, now how do I get rid of that cube? Yeah, I'm going to do the cube root. So we're going to do the cube root of y cubed, so that cancels out. But then we also have to do it over here. Don't forget to put your little 3 on there for your index. So then y equals the cube root of x plus 11 over 2. And then in function notation, it's the inverse of x of f of x equals the cube root of x plus 11 over 2.
Yeah.
You're just changing the equation.
No, it's now it's the inverse of
Just change it to
so you can actually solve it.
Now we're going to, we'll do this one together. All right. So write it down with me. Y equals the cube root of x plus 4 minus 6. So the first thing we have to do, remember we're going opposite with PEMDAS. So we have to undo the addition and subtraction first. Okay, but before I do that, I keep going too fast. I need to flip-flop my x and y. Okay, so that's my step 2. Step 3, solve it. So we're going to go plus 6, plus 6. So now I have the cube root of y plus 4 equals x plus 6. Now, how do I undo the cube root of something?
Times it by 3.
Not times it by 3.
Whatever it's called.
I take it to the power of 3.
Wait, can you get rid of the 4 first or no?
So you can't because
No, because it's under the radical. I have to get rid of the radical first.
So then that messes up the opposite of the PEMDAS.
36, 36, 36.
No, because a radical is radical is actually to the power of 1/3, right? Remember? Okay, so it's still an exponent. I see what you're saying though, because you see the addition. You want to undo that one first.
Yeah.
Yep. Okay. So what we end up with is x plus 6 to the 3rd. But what that really is x plus 6 times x plus 6 times x plus 6 equals y plus 4.
Well, we get rid of the 4 now, right?
Now we can get rid of the 4. Okay? But for this notation, we don't have to write all that out. Okay? So I can just leave this as x plus 6 cubed. And then how do I get rid of that plus 4? Minus 4. So it's going to end up being x plus 6 cubed minus 4 equals y. Hey, this is the formula for converting Fahrenheit to Celsius. So the way this would actually look, and I want you to rewrite this, Celsius equals 5/9 x, which x is actually going to be our Fahrenheit. So we're going to make that F minus 32.